Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Akilah binti Cik Mahathir. I'm student from Faculty Science, Computer and Network. Firstly, let me briefly explain what a number system is. A number system is a way to represent number using a specific base. So, what is the decimal number? The decimal number system is base 10 and use digits from 0 to 15. This is the system we use in daily life. And what is the octal number system? The octal number system is base 8 and we use digits from 0 to 7 and continue from 10 to 17. It is often used in computing because it can be easily converted to binary system. So, let's say the given decimal number is 3713.25 base 10. This number consists of integer part and fraction part, which is the integer part is 3713 and the fraction part is 0.25.
Decimal to octal.
Okay, how to convert the integer part? Okay, first, I will convert the integer part, which is 3713 from decimal to octal. To do this, I use the division by 8 method. I divide the number by 8 repeatedly and record the remainder each time. Okay, firstly, we look the number. Okay, we take 3713 divide 8, we can get 464 and the remainder is 1. So, we take 464 divide 8, we can get 58 and the remainder is 0. After that, we take 58 divide 8, we can get 7. So, the remainder is 2. After that, we take 7 divide 8, we can get 0. So, the remainder is 7. Once the quotients become 0, I stop dividing. Next, I read the remainder from bottom to top. From bottom to top. So, the octal number is 7201. Therefore, from 3713 base 10 to 7201 base 8. Next, I convert the fraction part, which is 0.25, into the octal. For the fraction number, I use the multiplication by 8 method. So, I take 0.25 1 x. So, 5 1 x, we can get 40. 2 1 8, we can get 60 and add 4. So, we can get 20. 2, we push behind. Okay. So, from 0.25 base 10, we can get 0.2 base 8. Since there is no remaining fraction part, the process stop here. So from 0.25 base 10 to 0.2 base 8. Okay, now I combine the octal integer part and the octal fraction part, which is the octal integer part is 7201 and the octal fraction part is 0.2. So we take 7201 plus 0.2 and we can get 7201.2 base 8. Okay, from the 3713.25 base 10 and we can get 7201 base 8. This is the final answer. Okay, how to convert the octal number to decimal number? Okay, now that we have successfully convert the decimal number into an octal number, the next step is to convert the octal number back into the decimal number. This reverse process is important because it helps us verify and confirm that our previous conversion is correct. The octal number obtained early is 7201.2 base 8. Okay, to convert an octal number to decimal number, we use the position value method. In the octal number system, first, each digit is multiplied by the power of 8. Second, powers increase from right to left for integer. Third, power decrease negative power for fraction part. Okay, first I will convert the integer part, which is 7201. Okay, first we should change the power of 8. Okay, 8 powers 3, we can get 512. 8 power 2, we can get 64. And 8 power 1, we can get 8. And 8 power 0, we can get 1. Okay. First, 7 minus 512 equal to 3584. And second, 2 minus 64, we can get 128. And third, 0 minus 8, we can get 0. And 1 minus 1, we can get 1. Okay, now I add all the value together. Now I add all the value together. 3584 plus 128 plus 0 plus 1 equal to 3713. So the decimal value of the integer part is 3713. Okay, next I convert the fraction part, which is 0.2 base 8. For the fraction digit, I multiply them by negative power of 8. So we take 2 powers negative 1, then 2 mul 1 div 8 and equal to 0.25. So the decimal value of the fraction part is 0.25. Okay, For the final result, I combine the integer part and the fraction part, which is 3713 plus 0.25 equal to 3713.25 base 10. Okay, this is exactly the same decimal number we start with, which proves that the conversion is correct. Okay. In conclusion, this video demonstrates two conversion methods. First, decimal to octal using division by 8 and integer part, then multiplication by 8, this fraction part. And second, octal to decimal using one positional value method, second power of 8. By applying both methods, we can clearly understand how different number systems work and how to verify our answer. By converting the number back from octal to decimal, we can verify that the conversion is correct. This shows that both methods are accurate, that's reliable. Thank you.